So David, we've talked about several things. I think changes in your pedagogy as a result of your exposure to SENCER, the applicability of SENCER to some of the larger goals that you have been working on increasing the success of people who have had less success in the past and less access in the past. But I'd really like to talk to you about the complexity of taking an idea like SENCER and getting it to take hold in a big, excellent institution that has R1 status and is a member of the AAU, that already has lots of reasons to think that it's doing lots of things right. So what kind of experiences would you like to report on that, and what kind of advice would you give to other people who are places where perhaps making larger curricular changes are a challenge?
Okay, so David, I think that one thing that I would start by talking about is just STEM education in general within AAU institutions, for example, and other major research universities, and then try to see how SENCER might be situated within some of that. Because if you look at, for example, Stony Brook, there are a number of efforts that are going on. We have something, undergraduate STEM initiative, which involves 20 faculty members working on a number of STEM projects across the university, physics, chemistry, biological sciences, engineering, and so forth. So if you look at the kinds of things that are going on, certainly the engaging undergraduates in research is a major sort of thrust, and that is growing, for example, at our university. This whole notion of scientific teaching and learning and using, approaching learning and teaching in a more scientific way based on research related to learning and that kind of thing. So you see that kind of element developing. Stony Brook, for example, just ran an institute along the line of scientific teaching where 25 faculty members participated. There's also a good amount of sort of discipline-based thinking, particularly as it relates to introductory courses and the problems that students have in learning problem solving and design and a whole bunch of elements like this. So I've been thinking a bit about sort of how SENCER might interface with some of the things that are going on. And it seems to me that perhaps SENCER, a strategy might be to situate SENCER within some of these major thrusts that are going on. That is to say, bringing together people that are looking at introductory courses so that it's not just about SENCER. It's about introductory courses in STEM in general, for example. And what are some of the strategies that people are using, and then infuse into that the SENCER kind of approach. This is the kind of challenge that I found, for example, at Stony Brook in relationship to SENCER. That is, so Gary Halater, as a faculty member in material science, he certainly has utilized a lot of the SENCER thinking in regard to the development of a minor in nanotechnology. So clearly his experiences with SENCER had a lot of impact on the way in which he thinks about that 6 or 7 courses that constitute the minor, how to integrate certain things related to civic activities, and having students reach out to professionals in the field and some of these sort of social dimensions around the work. So that's kind of my thinking, is that somehow with the AAU major research universities, one probably wants to look very carefully at what are the STEM education efforts going on in those places. If there's undergraduate research, is there a way of tying undergraduate research to SENCER, a SENCER sort of project, and cast it in that light? The sort of introductory courses issues and some of the things that are going on there. That's kind of...
So a kind of bringing this into the institution is your idea, rather than having the institutions come to...
That's what I'm thinking. I'm thinking where there's a critical mass of faculty members that are already working on STEM education issues. Can we take SENCER to that cluster, that group of faculty
You
members?
sort of did that with your help at the Long Island meeting.
Yes, yes.
When it was actually hooked to a major general curricular reform effort, as I recall.
Yes, and in fact, I expect additional payoff from that because we're just beginning to implement the new general education. And in fact, we'll start this fall to implement the new general education. And that new general education has both a science and society kind of requirement. It also has an understand technology requirement as a part of it. Also, several people are talking about themes. That is, can students satisfy general education? I know this is not new, but the idea of sustainability, other ideas, can students take a cluster of courses so that there could be a community built around whatever? So I see SENCER as playing a bigger role as faculty members think beyond sort of the individual courses to clusters of courses and communities forming. I think that, in fact, one of the faculty members in the School of Marine and Atmospheric Sciences talked to me after the SENCER meeting that we had at Stony Brook, that conference, the regional meeting, and he talked to me, he got very excited. He's a leading distinguished professor in marine sciences, and he started thinking about these issues of sustainability and how climate issues and all of this kind of thing, and that it would be nice to develop that theme so that we have a fairly significant number of students meeting most of their general education by
Focusing on the North Shore.
Focusing on Long Island Sound, focusing on some other kind of dimension in that way.
So we talked about another occasion about some of the systems thinking work that you were, as I remember, systems engineering, other things that you thought was an appropriate kind of substrate for the SENCER approach.
Yeah, so as far as...
Correct me if I'm wrong about what we...
So within technology and within engineering, this whole sort of notion of infusing more systems thinking. To be quite honest, much of the engineering work and focus seems to be done within a fairly narrow context as it's practiced currently. And so as we try to expand international opportunities for engineering students, for example, the whole notion of there are a whole bunch of factors that influence the kinds of designs that people do. For example, when you talk about an area like nanotechnology, well, for the typical Stony Brook student, the Stony Brook student is thinking about very high-end kind of applications of nanotechnology, robots in the circulatory system and doing repair and work and all of this kind of thing. Whereas if you look at globally, what are applications of nanotechnology that might save lives, etc., issues of clean water and certain, so the very nature, it's very not easy to get, I think, faculty within many areas to think in that kind of way, that you really should be preparing students not just to do design on Long Island or design in the U.S., but you should be preparing students to do design that is global, and therefore they need to understand something about global problems. As technology gets to be used in different places over the world, they need to think about what is to be designed. What motivates the technology that gets designed. So this kind of systems thinking, this kind of social, cultural dimension, all of these kinds of things need to be brought into play. So I see a significant role for SENCER, for example, within engineering in that way.
Because it asks people to think beyond the very specific problem to the context of the problem, is that?
It gets people to rethink the issue of context. That is, there's almost an implied notion of context, almost an unconscious context that people impose on themselves as a result of their own upbringing, their environment, etc. So they may think they are doing universal design, but they're very much constrained by their own sort of mental view of what are the problems and issues and how do people relate to each other and what do people have available to them. So there's all that kind of notion. And so to try to push that into a broader arena, I think SENCER has a great idea. In fact, as we're talking, I'm thinking, wow, I'd love for you to talk to our engineering faculty members as they think about design projects and whether there's a role that SENCER might play in introducing people to new design projects.
It's a perfect, it seems to me, it's a perfect application of a kind of engineering principle, right?
Sure.
Of testing something under different conditions.
Absolutely.
And so that if you were to think about a solution that you propose for the North Shore,
Yes.
testing it under conditions of different atmospherics or different cultural acceptances or a whole
Absolutely.
variety of things provides
Absolutely.
something the engineer needs. I thought that was one of the things that our West Point colleagues were doing is, not only designing a better battery or lighter battery pack for soldiers to carry into the field, but working on the very hard problem of finding out whether they would actually do it because they would trust it, or they would,
Absolutely.
or whether some slight overuse of battery for another purpose might weaken the overall effect of the battery. So it goes well beyond whether it's a great design, but whether it'll get used and how and under what circumstances.
Yeah, it calls into question the very notion of what is a great design. Okay, that is, that there are technical, requirements and tests that people run, and so, you want the thing to work in some context. But what is a great design?
And that actually is an interesting way of talking about education itself. What is a great design for learning?
Absolutely.